little. It says probability, relative frequency. Okay, frequency. What does frequency mean? Well, if you say something's very frequent, oh, that happens frequently. So what is frequency? How often? Yeah, frequency is how often something happens. Relative means that you're comparing it to something else. Like your relatives, those are the people that you compare within your family. Relative frequency is when we take a number and we compare it to how many times its total might be. So, you know, if you looked at how many times you came to school during the year relative to the total number of times you could have come, that's what a relative frequency might be. So like if you came 3 out of every 4 days, your relative frequency would be 0.75 or 3/4 or 75%. So we can express it as a decimal, we can express it as a fraction, we can express it as a percent. Oh, I wrote 6. I should write 7. Oh no! Am I on the wrong page? I totally am. 5, 6 is what I want. This, geez. Stop, start. My bad. So now I have the wrong picture for the YouTube video. That's fine. I'll change it. Oh boy, probabilities. Yeah, I was thinking to myself, geez, this isn't what I remember going over in my mind last night. Probability distributions. Oh, okay, my bad. Okay, probability distributions. If you look at all of the possible outcomes that can happen, and we talk about the probability of any one of those happening, and then we compare that to another event possibly happening, and another, we can add them all up and we can compare those probabilities. That's what they begin by putting together. So for example, if we look at dice, and we look at this particular layout of rolling dice in pairs. If we look at all of the different combinations, and the combinations would be thought of as the count on the dice. So what are all of the different combinations that we can get? Hi.
Hey, good morning. Happy Drench Day.
Yeah, thank you. It's me, I guess. It's a Hannah and Haley thing for some reason.
That's what they said, so I had to come over and say hello.
Yeah, I know. I don't get it, but just trying to be the way I am. Yeah, working on it.
1, 2, 3.
Well, could you get a total of 2? Can you get a total of 1?
Yes.
No, because you have 2 dice and they each have a 1 on them. So you could get a count. So your count could be like 2. Can you get a 3? 4, 5, all the way up to, what's the most you can get on dice? You get 2 6s, which is going to be a 12. So then the question is, how many different ways can we come up with a 2? So how many different ways can you get a 2? One way, right? Just a pair of 1s. So we look at this count here, a pair of 1s. So we can get 1 out of a total of, how many different combinations are on here? So if you roll 2 dice, how many different pairings can come up? There's 36 of them. Yeah, each die has 6 sides. So you have 6 times 6, you have 36 possibilities. So this comes up as 1/36. How many different ways can you come up with a 3? 2, yeah, if you just look at it diagonally, a 1 and a 2 and a 2 and a 1. So that's gonna be 2 out of 36. How many ways can you come up with a 3? I'm sorry, a 4. A 4, you can get a 3 and a 1, a 2 and a 2, and a 1 and a 3. So that's 3 ways. And then how many ways can you come up with a 5? So again, if you look, you can kind of count them diagonally. You see you have a 4 and a 1, a 3 and a 2, a 2 and a 3, and a 1 and a 4. So that's how many ways? Are you following me? Am I going too fast? Am I okay?
Yeah.
So how many ways is that? 4 and a 1, 3 and a 2, 2 and a 3, 1 and a 4. That's 4 ways. So 4 out of 36. So what ends up happening is this ends up being the probability of getting some count. And what we could do is we could say that that's equal to x. That's what the book does. So x is this variable. And here, x is what our count is. So for example, this 1/36 is the probability of a 2. And the probability of a 6, how many ways can we get a count of 6? Can you see the pattern in this thing? Maybe I need to show it to you. Bring it up here. I guess I've seen it so darn many times. And it's quick for me to recognize, and I think you'll see it real quickly here. You say 5 ways? So here's your combination. Whoops, ooh. There's your combination of 2. Here's your combination of 3. These are the combinations that result in 4. So then resulting in 5. And then here are the combinations that result in 6. Oops. So you see how they're oriented diagonally? So you've got 1, 2, 3, 4, 5. 5/36. So if you're playing something with dice and you roll, the chances of you getting, hi, you're here, awesome. The chances of you getting a total of 6 is going to be 5 out of 36. This is going to be getting hard to squeeze in here. So what's the probability of getting 7? There's 6 of them, 6/6, or 6/36. And then the probability of getting 8, there's 5 of those. And the probability of getting 9, 4 of those. So it goes right back down again. So this is 5/36, 4, 3, 2, and then 1/36 is your chance of getting a pair of 6s. So this is like it's a probability table based upon the frequency, how often it shows up. So the number on the top for our probabilities is how frequently it can occur, and the number on the bottom is going to be the total. That's how we get the fraction. Now you can turn these into decimals, and they do it in the book, but you end up with repetends, and they end up getting to be kind of confusing. I don't know, I'm not real big on having those in repetends. But here they have them. You can take a look at the book if you want. I'm fine with you leaving pretty much, unless you need a percent, I'm fine with you leaving pretty much everything as a fraction. If we leave them with a common denominator, it's kind of nice, because if we total these up, what do they all add up to? If we take every possible, 36 out of 36, we take every possible combination of die, that's going to end up with a probability of 1, or 36/36. So it's like if you flip coins. You know, with coins, the probability of a head, and we write probability of an event like this, you maybe remember this from the past. The probability of getting a head is what? You flip a coin. 50% or a half. So a half or 0.5 or 50%. And then what's the probability of a tail? It's the same thing, isn't it? So when we put these together and they add up to 100% or 1, these are said to be complementary events, because they add up to a probability of 1. With all of these, we have to add everything together, and then they're complementary. So, you know, you could say, well, what's the probability of getting an even number? And you would add all of those up. And the complement to that might be the probability of getting an odd number, because between the two of them, they add up to 1 whole. And we can use complementary events to do probabilities if we want. Because if we knew, for example, that somebody had a cheating coin, like maybe Marvis has got a coin that's weighted on one side, so it always comes up heads. Or most of the time it comes up heads. And if that coin, for example, had a probability of a head being like 75%, for that same coin, what would be the probability of a tail? It'd be 25, yeah. And we can find that by taking 100% and subtracting 75%. Or taking 1 whole and subtracting that fraction. 75% could be thought of as 3/4. So all of this here with the dice, this is all based upon the idea that it's not biased. So we call unbiased. And that would be unbiased or fair. And what that means is that everything is equally likely to occur. And then here's a little bit of notes that I have on that page. When you do this type of notation here, we read this, the probability of getting a 2, the probability of getting a 6, or a head or a tail, or whatever it is that we're working with for probability. So, here's a table. A lot of what we're going to be doing in this lesson is we're going to be interpreting the information to try to come up with what the probability is. It's not going to be as cut and dry as dice or a spinner with colors and things like it was in middle school. So this is real information. In the United States, O positive blood, 38.4% of the U.S. population is O positive. I'm A positive, 32.3% of the U.S. population is A positive. Do you know what your blood type is?
O negative.
You're O negative? Do you know what yours is? No? Someday you might know it. You're O negative. Are you really O negative? You are one rare bird.
Half of my family is too.
Really?
So,
Yeah, it's recessive.
yeah.
Doubly so.
Caleb doesn't. He has A positive, which is my dad.
He's A positive, huh?
Yeah.
So your dad, we could spend 20 minutes, 30 minutes learning about what genetics is. I can tell you what the genetics of your parents are when it comes to blood type, just knowing that information. It's real definitive. That's pretty wild. 7.7% are O negative. So what's the probability that a person in the US has type O blood? So all these add to 100%. How do you go about figuring out the percent that have O? Yeah, you gotta add those two, don't we? So it's gonna be what, 46.1%. So almost half of the US population is type O. But type O is recessive. Do you understand that with genetics? Number dominant and recessive traits, you talked about that with Mr. Baumgartner, right? Yeah, and you would think, well, geez, because dominant is dominant, there are more people that have dominant traits, right? But it's actually just the opposite in human populations. There are more people with recessive traits. So, the probability that a person with O is O negative. So that's a little bit tougher. So what we're doing is we're restricting. We're restricting things down to type O, and we're saying out of only the type O, how many, or what's the probability that a person is O negative? So how do you think you have to go about that one? Say it again?
46.1
Yeah, so your 46.1, that's your total. And that comes from all of your type O's, which are going to be 38.4 and 7.7. And then you're saying the O negatives. So we take 7.7 and we divide it by 46.1. The percents are going to cancel, so we're going to end up with a decimal. And I think, what is it, 7.7 divided by 46.1 is 0.167. And it keeps going. So then, how do we change that to a percent? Two places. So it's almost a 17% chance that if you're O negative. Is your mother O negative?
Yeah.
And your dad's A negative?
A positive.
Really?
I'm pretty sure. I'm gonna feel it, though. Might be detailed.
I feel like he's something negative if your mom's negative. And you're negative.
I thought him and Caleb were A positive, but I'm not sure.
Well, yeah, that's right, though, because there's two alleles. If your dad is positive, he could have a positive and a negative allele for what they call Rh, which is what that is. That's Rh factor. So if he was negative and he contributed that allele to making you, and your mother is negative, she has to be negative on the two alleles. So then you could be negative, yes. So that was a 50% chance of you coming out negative. Yeah, that makes sense. But then your dad on the A, he's got an A, and then he's got a recessive.
Yeah.
And your mother has two recessives, and those two recessives came together to make you O. Yeah, genetics of blood is pretty wild. I think it's pretty cool. So odds versus probability, they bring this up. It says, odds are written in terms of how often something will or will not happen. So if you have a 3 out of 4 chance of winning a drawing, they say, the probability of winning is 3/4. So if it's 3 out of 4, that's like saying here 1 out of 36. And that's the odds of getting a 2. So the odds of winning in a drawing when you have a 3 out of 4 chance would be 3/4. So 3 out of, so you draw 4 times, and that's a winner, and that's a winner, and that's not. So this is 3 out of a total of 4. So it's the way we read it and the way we say it, odds are different than probabilities. When we talk about odds, we say a 3 to 1. and the 3 to 1 gets added together for the total. It's like 3 chances of winning to 1 chance of losing. So in this case here, if that's the case, and these 3 are wins and that's a loss, you have 3 times the chance of winning as you do losing. So I don't know if you guys look at betting odds for football or basketball or baseball teams or anything, but they write those odds in that way. They might say that, you know, a team has like a, they come up with really huge numbers, but they might say that there's a 50 to 45 chance of a particular team winning, which would mean that they would have a 50 out of 95 chance or probability of winning. This team would. That team's probability would be 45 out of 95. So together, they add up to a total of 95 out of 95. That might be all we need to do. Let's double check. I think, yeah, it seems like that's it. When we do something like this where we are taking a piece of the data, we took just the people with O blood instead of all people, that's called the conditional probability. Given this subset of things, what's the probability? You know, like, you might look at all of these here, and you could take, well, we're gonna take the subset of even numbers. So now what we're gonna do is we're gonna get rid of all the odds. What is the probability of getting doubles? So we don't worry about the odds. So how many different things are we looking at total? Instead of 11, we now have only 6 different events. We get the evens of 2, 4, 6, 8, 10, and 12. So what would be the probability of getting doubles if it's an even count? So our even counts are 2, 4, 6, 8, 10, 12. How many of those are going to be doubles? Well, we got to go to this. This right here, we got to count this. So it's got to be even, and it's got to be doubles. How many are there? Well, there's, we don't take it times 2.
Where are we counting the pairs or how many dice?
So a pair is an event. And what we're counting with this is how many times doubles could show up if we were talking about an even count. So something like this here, that we don't want to consider these odds because we're saying the conditions are that it has to be an even. So we got to get rid of all of these odds. Shoot, this thing sucks. I don't like this board at all. There we go. So we sort of crossed out all of the odds. So now we're left with evens. Is this an odd? That's an odd. So there's a pattern to it, right? So now, how many total are there? We just crossed out half of them, didn't we? So instead of there being 36 combinations, there are how many combinations? There's 18 of them. And how many of those are doubles? There's 6 of them. So if you get an even number, the probability of you coming up with doubles is gonna be 6 out of 18, which would be 1/3, or 33 1/3%. That's a conditional probability. So I think that's everything that you need, should be. This is just a graph of these values here, showing how as we go higher with our probabilities, those high probabilities come from having a sum of things like 5 and 7, 6s and 8s and 9s. We did a fair amount of this kind of stuff in 7th grade, actually, less of it in 8th grade. So there's your work, 284. It's 1 to 16, 21 and 22. So are you here for the week? Are you here for the whole week? You're not gonna go down to Juneau again? That's where you were, right? Yeah, I figured so. Okay, good. So